We'll be starting with the basics of casting. So any material which can be melted can be casted. That is the baseline. What materials can be used in casting? Anything which can be melted can be casted. So, and I'll compare two materials which usually appear during casting. The first is aluminium. The second is cast iron. Aluminium's melting point is around 900 degrees Celsius. So it is much easy to melt it and cast it. So it is one of the best material. It is actually it is the best material. Anything like our engine blocks are made from aluminum or aluminum alloy casting, while cast iron is another good material which has high carbon content. It is a bit brittle, so machining of cast iron is difficult. We can't, so when we try to machine it, the chips will not form properly and the surface properties may get bad, but it can absorb vibrations very good. And we can use cast iron to make ductile iron pipes. So even though it is brittle, we can add spheroidal graphite SG or nodular cast iron. This is a special type of or special category or alloy where it can be used to make it ductile as a material instead of brittle. Otherwise, iron or cast iron is very brittle. And on an opposite side, steel is not that brittle. And all the lathe beds, whatever lathes we have in our workshop, all the lathe bed, the position on which the lathe machine is standing are made up of cast iron. And on a side note, resilience means shock absorbing capacity within elastic region. So that is an extra note I have made. And some of the allowance, when we are going to design a mold for casting, we should take care of some of the specific occurrences or processes which occurs. One is the blow mold, that is one of the casting defect. Another is we should take care of internal residual stresses. When we are going to pour the material, there will be internal residual stresses. And in terms of accuracy, we should take care of shrinkage allowance, which means the material is going to shrink when the material is going to solidify from the liquid phase, it is going to shrink. And there are 2 or 3 types of shrinkage which takes place. So we need to take all those into account. And hence, when we are going to pour the material, we need an extra material. That's what I have mentioned on the side note over here. Machining allowance means obviously when we are going to cast the surface properties may not be as per our requirement. There could be some surface defects, and in that case we need some extra allowance so that we can machine the top surface and get a proper clean smooth surface from internal side. Then we have draft or taper allowance. Over there also extra material is required. What does draft or taper allowance means? If we have a straight parallel surfaces somewhere in casting, it would be difficult when we are going to take out that solidified part from there, because the sand may not be able to come off from the surface of the metal. In that case, what we do is we make it a bit taper. So if we have this much requirement, we keep the bottom side as it is and slightly make it tapered from the top. So what does that mean? We are going to have some extra material which is used over here, but in this case we can easily take out our material, our solidified cast. That's what means. Distortion allowance is a bit difficult thing. Somewhere we need to use extra material, somewhere we need to use less material, so distortions may occur. And that is a bit complex, where we have a very thin but long part made using casting. Shake allowance means when we are going to shake the mold while taking out or while preparing, we are going to shake it and ramp it so the sand is properly fixed. And in that case we need lesser actual material of the metal to be poured. So that is shake allowance. And there are two main types of casting: expandable mold casting and permanent mold casting. So we'll go through it. Expandable mold casting means it is sand casting or cell casting or investment casting. In this case, we make a mold pour the material and break the mold. So that is the main difference. Over here, we make the mold, pour the material in the mold and break the molds. That means the mold which is prepared is only used once. Over here, in the opposite case, when we have permanent mold casting, the examples are die casting. Over here, we make a mold and use it over a period. So the same mold will be used to make the same product multiple times. And over here, obviously, when we are going to use the same mold, the products which we can make are made up of plastic or non-metals or usually aluminum. Fine. And pattern allowance is the difference between the dimensions of the casting and the pattern. So that's all we have. In the next video, we'll start with the general diagram of a casting process. Thank you.